And welcome back. As we go ahead and take a look at our next type of loop, which is going to help us with navigating arrays, that is the for each loop. So the reason why we're bringing this up is because we are having a discussion around how to cycle through an array. So as we've already seen, we can use a for loop to cycle through all the elements in an array. So for example, we have this double array called A. It's size 10, and all we can do is use a for loop. We say int I equals 0, I is less than a dot length, I plus plus, and then we can do things like print out the elements in that array. Now, this is being brought up because in Java there are these things called collection classes. And collection classes are classes whose objects store a collection of values. And we haven't really looked at these yet too much, but it's just something to kind of be aware of. The standard Java libraries actually contain several definitions of these so-called collection classes. And while this for loop that we're looking at above works for arrays, it doesn't work for all these collection classes. And when we start encountering things like this, then we might say, well, how do I get to all those pieces that are in there? So Java actually has another kind of loop that can cycle through all the elements in a collection, even though there's no indices for those elements. And that is the for each loop. This new kind of loop is known as a for each loop, or sometimes you'll hear it referred to as an enhanced for loop. These for each loops can be used with arrays as well with objects of collection classes. And now, since we are having a good understanding of how to use arrays, is a good time to be able to introduce these for each loops so we start getting familiar with them. So the following code ends with a for each loop equivalent to that regular for loop that we just saw earlier. So we have double array A equals new double 10 for double element colon A and then system out dependent element. So if we want to interpret what that code actually means, a good way to think about it is saying for each element in A, do the following. A, of course, referring back to the array. You'll note that the element has the same type as the elements of the array. So in this case, we had a double that was declared, and the array itself was also double. Therefore, the variable, like element in this example, must be declared in the for each loop as we have done. So if you had a integer, then you would have to put a integer type identifier in front of that variable name. Now, if you attempt to declare element before your for each loop, you're like, well, I can declare it outside, right? Because like with regular for loops, you can do that. You can say that, for example, if you have int I, you can say int I, and then you can initialize that outside your for loop, and then you can come and use it, or you can do inside the for loop. However, doing this in the for each loop, you'll get a compiler error message. So the general syntax that we're looking at with a for each loop, when we're looking at this array, is going to say for array base type, the variable colon array name, and then we'll have some kind of statement for the code that goes inside of that for each loop. Now, be sure that you use a colon, not a semicolon at the variable. So right in here, you'll notice this is a colon. It's not the usual semicolon that we're used to using because, again, this is a special type of loop that we're going to be operating with. Now, even though we've used element in this example, you can use any legal variable name for that variable. And although it's not required because you can have it do other things, this statement part right here typically is going to have some reference back to the variable, whether it's a print line, whether it's some kind of operation. But again, it's not always going to be that way, but it is very typical. Now, when the for each loop is executed, the statement is executed once for each element of the array. Specifically for each element of the array, the variable is then set to the array element, and then the statement is executed. The for each loops that we're looking at right now can make your code a lot cleaner and a lot less error prone because you have less moving parts. You don't have three independent components of that for loop that you have to manage. You only have one. Now, if you're not using the index variable in a for loop for anything other than to cycle through all the array elements, then a for each loop is very preferable. So, for example, if we say for double element in A, sum plus equals element, this is preferable to saying for int I equals 0, I is less than a dot length, I plus plus, sum plus equals a of I. And you might say, well, why is that? Well, here, what are we also doing? We're adding back in whatever's in that indice. Whereas like here, we're doing the same thing, but we don't have to reference what the actual value is. Notice here we have in A, and this is element. And even though, yes, these examples show two different types, this is a double, this is an integer, both arrays are doing effectively the same thing. Now, because these two loops in principle are doing the same thing, and when you start looking at it, the second one mentions an index, I, that is not used for anything other than pretty much enumerating the array elements. Therefore, the syntax for the for each loop is a lot simpler than that of the regular for loop. However, you should leave the following for loop as is and not attempt to convert to for each loop. So if we look at this example, we have for int I equals 0, I is less than equal to length, I plus plus, a of I equals 2 times I. And why don't we want to convert this one? Well, because this for loop is using index I in the body of the loop and uses it in an essential way, we're modifying the values here within the array. It does not make sense to convert this for loop to a for each loop. So anytime you start doing things, for example, and notice here, we're modifying what is stored in that array. For each loop is probably not your best option here. And so let's go ahead and take a quick example here with a for and a for each loop. And so I'm going to go ahead and quickly write up some sample code. I have a very basic array here just to test this out. So let's just say for int I is equal to 0, I is less than r dot length, and I plus plus. Then what do we want to do inside this loop? Well, let's just have this one. Just do system.out.println, and let's just have it print out r of I, and we'll take that times 2. So we're just going to print out the double of this. Now, of course, we can make this more complex. We can do other things in here. So, for example, if I want to put if statements and stuff like that in here, I can do well. But I'm, again, keeping it simple just for quick demonstration purposes. So let's take that exact same code and now rewrite it into for each loop. So I'm going to do for, again, same thing as we had before, int, because what is the type of my array? It is an integer. And I'm going to call it element, or I can abbreviate it as ELE. That's another shorthand that commonly is used. And then colon, and then I reference it back to whatever array I want to use, which is ARR. And then again, I can then just grab this println statement, but instead of saying R of I, all I have to do is say ELE and say times 2. These, of course, are going to do the exact same thing. And if we run this code, we get outputting the values using a for loop, and we get 0, 2, 4, 6, 8, 10. Outputting the values using a for each loop, 0, 2, 4, 6, 8, 10. And you can see just how much cleaner this is, because again, think about how many components we have here. We have the potential to make errors. Like we may initialize to the wrong value. We may go too many or too little iterations here through that loop or through that array. And here, if we have the wrong incrementer or decrementer, that could affect things as well. But here, it's pretty straightforward. It's going to pull every single one of those elements and it's going to use them. So hopefully it gives you a good, quick example of how to use a for each loop, and hopefully you'll find this useful in writing your own programs when it comes to whether or not you want to use a loop.